there is no warning, no tremor in the ground, no distant roar in the sky. One night, you look up, and the moon is simply gone. The stars are still there, scattered like shards of ice. The Milky Way burns faintly in the background. But that pale, familiar disk, the one humanity has looked to for thousands of generations, has vanished. It is a hole in the sky. A silence so deep it feels like the world itself is holding its breath. Imagine the confusion, the first moments of disbelief. Millions of eyes turning upward, searching for something that will never return. Would we notice instantly? Or would the absence only become real when the tides failed to rise? When the night itself felt too dark? As though the universe had forgotten to light its lantern. The moon has always been more than just a rock. It is our clock, our companion, our storyteller. Its phases have measured our months. Its glow has guided lovers and wanderers, soldiers and sailors. Before the written word, before civilization itself, the moon was there, whispering to us across the dark. Now, imagine that voice gone dot. No eclipses, no silver reflections across the ocean, no reminder that the universe moves in cycles. Would we feel smaller? Would we feel lost? But the true shock wouldn't just be emotional, it would be physical. The moon is not just something we look at, it is something that holds us together. Its gravity tugs at the oceans. It steadies the tilt of our planet. It shapes the rhythm of life itself. Without it, everything begins to shift. This is not a story about science fiction. It's about reality, stripped of one of its most fundamental anchors. If the moon were to disappear suddenly, without warning, the Earth we know would be gone. Slowly, then violently. So, what happens next? What if tonight you walked outside, and there was nothing waiting for you in the sky? The moon has been called many things: a guardian, a mirror, a ghostly lantern in the sky. But before poetry, before mythology, before we ever dreamed of walking on its surface, the moon was already at work, silently, relentlessly, shaping our world from a distance of 384,400 kilometers. We think of it as a passive object, a glowing ornament pulled along by gravity. But that illusion is only skin deep. In truth, the moon is active, constantly exerting force, constantly influencing the Earth, and without it, nothing would stay quite the same. Let's start with the most immediate force you'd miss. Gravity, the tug of war that moves the sea. Every day, oceans rise and fall, twice high tide, low tide, a rhythm as ancient as the planet itself. This isn't just some surface ripple. It's the direct result of the moon's gravitational pull on the Earth's oceans. As the moon orbits, it stretches Earth's water toward it like a slow-motion whirlpool in reverse. A massive, planetary-scale bulge of water follows the moon around the globe. Without the moon, tides would still exist, but they'd be shadows of their former selves. The sun also causes tides, but only about 30% as strong. Without the moon's dominant pull, our tides would shrink dramatically. Coastlines would become eerily still. Estuaries, coral reefs, and intertidal ecosystems, all built on tidal flow, would face collapse. But tides are more than just water movement. They churn nutrients, shape climates, regulate temperatures. Without the moon, this global stirring slows down, and ecosystems begin to unravel. Earth's balancing act. Now zoom out. Look not at the oceans, but the planet itself. Earth spins on a tilted axis, about 23.5 degrees. This tilt gives us seasons, winter and summer, spring and fall. It controls the angle of sunlight, the length of days, and the migration patterns of countless species. But here's the twist. That tilt is not stable. Left on its own, it would wobble wildly, swaying between near 0 degrees and extremes. Up to 85, without correction, Earth would tip chaotically over tens of thousands of years. 1 century, Antarctica might be tropical. The next, the equator could freeze. The moon stops that from happening. Its gravity locks our tilt into a tight range, like a hand steadying a spinning top. Without it, Earth would become unstable. A climate roller coaster no civilization could easily survive. This isn't just theory. Mars, which lacks a large stabilizing moon, experiences chaotic swings in axial tilt. It likely once had liquid water, maybe even life. But without a lunar anchor, its climate spiraled, and so did its habitability. Life, measured by the moon. Life on Earth evolved under the influence of the moon. Literally, nocturnal animals adapted to lunar phases. Coral reefs spawn according to moonlight. Even human sleep cycles, circadian rhythms, are subtly entrained by lunar brightness. Some studies suggest that our ancestors, sleeping under the stars, were wired to wake more easily on full moon nights. And beyond biology, there's time itself. Our calendars, the very structure of days and months, are lunar in origin. Month comes from moonth. A complete lunar cycle is 29.5 days. Many ancient cultures, including the Babylonians, Hebrews, and Chinese, based their calendars entirely on the moon. It was the first cosmic metronome we ever had. Cosmic shield, or silent sentinel. There's also a speculative but fascinating theory that the moon might shield us in ways we can't fully measure. Its presence could reduce the number of catastrophic asteroid impacts Earth receives. By simply being there, it acts as a gravitational net, capturing or deflecting debris. And while this protective role is debated, one thing is clear. In the dance of solar system dynamics, every mass matters. Removing a large object like the moon would alter the gravitational landscape around Earth, potentially exposing us to greater risk, not just from rocks in space, but from long-term orbital shifts. The illusion of stillness you don't notice. It, when you look up, it just hangs there, pale and quiet. But in that stillness is power. The moon is a silent regulator, an invisible architect of stability. Like the counterweight in a clock, it doesn't make noise, but it makes everything else work. If it were gone, Earth wouldn't explode. It wouldn't flip overnight. But slowly, subtly, and then catastrophically, the balance would begin to fail. Civilizations rise in stable climates. Life thrives in predictable rhythms. The moon ensures both. Its disappearance would mark the beginning of Earth's long unraveling. So the question becomes, how long could we hold on? How long before we feel the pull of absence in tides, in seasons, in our minds? In the beginning, it seems like nothing has changed. The waves still come and go. The surf still hums against the shore. But beneath the surface, in the deep lungs of the Earth, something has shifted, something subtle, something irreversible. The tides have lost their master. For 4 billion years, the moon has whispered to the oceans. Twice a day, it has pulled them forward and let them fall back. This gravitational dance has carved our coasts, shaped our harbors, and stirred life into every crevice of the sea. Now, the silence begins. The moon's grip on water, Tides aren't caused by wind or storms. They are gravity made visible. A direct handshake between the Earth and the Moon. As the Moon orbits, it stretches Earth's oceans into an elongated shape. There's a bulge on the side facing the Moon, and another on the opposite side, caused by inertia. As Earth rotates, different parts of the planet pass through these bulges, creating the rhythmic rise and fall of the sea. In most coastal regions, this results in 2 high tides and 2 low tides each day. These aren't trivial fluctuations. In places like the Bay of Fundy, tides can swing over 50 feet. That motion powers marine ecosystems, cools coastal waters, and pumps nutrients between ocean layers. Take away the Moon, and you take away 70% of that tidal force, a planet out of breath. Imagine the global ocean as a living lung. Tides are how it breathes. They churn warm surface water with cooler depths. They push oxygen into nutrient-rich zones. They drive thermaline circulation, the global conveyor belt of currents that redistributes heat from the equator toward the poles. Without strong lunar tides, this breathing slows coastal regions, especially in shallow estuaries and deltas, would begin to stagnate. Sediments would settle instead of moving. Pollution would linger. Algae blooms would surge. Coral reefs, which rely on tidal flushing and precise salinity balances, could bleach or die en masse. Fisheries collapse. Shorelines begin to shift. Mangrove forests, dependent on tidal zones, shrink back and vanish. The Moon doesn't just move water. It sculpts life. Chaos in the currents. Now consider a deeper, stranger effect: the long-term breakdown of global ocean currents. Tides help regulate the Atlantic meridional overturning circulation, a key part of Earth's climate engine. It moves warm water north and brings cold water south. Without it, Europe freezes, the tropics overheat, rainfall patterns shift across continents. This conveyor belt is already slowing due to climate change. Without the Moon's extra push, it might grind to a halt even faster. The result: an unstable climate mosaic with flash droughts, mega floods, and food insecurity on a planetary scale. Even small changes in ocean temperature can amplify hurricanes, alter monsoon cycles, and trigger feedback loops we can't control, all from the absence of a silent satellite. Life at the edges. Tidal flats are some of the most biologically rich zones on Earth. They support crabs, clams, seabirds, and microorganisms that feed entire food chains. Many species time their mating, nesting, or feeding to precise tidal schedules with reduced tides. These cycles collapse. Horseshoe crabs, ancient creatures that spawn en masse during high tides, would lose their rhythm. Migratory birds that feast on the tidal bounty would find empty mud. Sea turtles, which rely on tides to guide hatchlings back to the ocean, could vanish from entire regions. The disappearance of one celestial body causes extinction cascades across thousands of biological niches. Stillness is not peace. You might think a calm ocean sounds peaceful. A glassy surface, undisturbed by tidal rise or fall. But this stillness is not peace, it's stagnation. Storm surges from hurricanes become more destructive without competing tidal movements to buffer them. Coastal erosion increases as wave energy concentrates without regular tidal redistribution. Saltwater intrusion creeps farther into freshwater systems, poisoning agriculture and groundwater. Some low-lying island nations, already clinging to survival, might vanish faster without the tidal resilience they've always relied on. And for the first time in human history, we would have to redraw the meaning of the sea, the death of the intertidal clock. There's one more loss, one we rarely consider. The moon gave our ancestors not just light, but time. In the absence of modern clocks, coastal peoples tracked time by the tides. They knew when to fish, when to travel, when to harvest seaweed or escape the incoming swell. These rhythms were encoded into language, story, ritual. With the tides flattened, this ancestral timekeeping fades. Cultures lose one of their deepest, intuitive connections to the natural world. The moon's absence doesn't just silence the water, it silences memory. Asterisk. And so we ask, what happens when something ancient disappears? Not with noise, but with a vanishing of motion. Would we even know how to grieve the absence of a rhythm? And if life on Earth emerged from the tides, can it survive without them? The moon is gone, but the Earth keeps spinning. At first glance, nothing seems different. The stars still turn, the sun still rises. But over time, over decades, centuries, millennia, something begins to drift. Quietly, catastrophically, Earth starts to wobble. Not the gentle procession we've always known, the slow pirouette of a stable world, but something deeper, unsettling, a change in the very axis of our planet's identity. Without the moon's stabilizing force, Earth becomes unpredictable, and everything we thought was permanent, seasons, climates, coastlines, cultures, begins to slide. Tilted from the start, Earth spins on a tilted axis, about 23.5 degrees off vertical. This isn't random, it's a consequence of ancient collisions, gravitational tugs, and celestial chaos. That tilt is what gives us seasons. Summer when your hemisphere leans toward the sun, winter when it leans away. But the miracle is that this tilt has been stable for hundreds of millions of years, not perfectly fixed, but confined to a narrow range between about 22 and 24.5 degrees. Why is this important? Because axial tilt determines climate. A slight change in that angle can mean the difference between rainforests and deserts, between ice sheets and fertile plains. A stable tilt means long-term climatic predictability. It means civilizations can rise, crops can grow, ecosystems can thrive. Now remove the moon, and that delicate balance is over. The moon as a gyroscope. Think of the Earth like a spinning top. It wants to stay upright, but outside forces, gravity, internal movements, cosmic nudges are always trying to knock it off balance. The moon acts like a massive gyroscope, pulling the Earth's equator and stabilizing its spin. It suppresses wild variations in axial tilt. Without it, those forces start to win. Simulations by planetary scientists suggest that without the moon, Earth's tilt could become chaotic, swinging between 0 and 85 degrees over long time scales. That's not just theory. Mars is the cautionary tale, the Martian warning. Mars doesn't have a large moon. Its tiny moons, Phobos and Deimos, are more like captured asteroids. The result? Mars wobbles a lot. Its axial tilt has ranged from 15 to 35 degrees, and possibly more, over millions of years. This instability likely played a role in the loss of its atmosphere, the disappearance of surface water, and its inability to sustain life. Now imagine Earth on that same path. A few degrees more tilt, and the Sahara becomes a jungle. A few degrees less, and India becomes tundra. The poles might warm while the equator freezes, or the planet could tip so far that one hemisphere faces the sun for months at a time, while the other plunges into darkness. This isn't science fiction, it's orbital mechanics. A world without seasons, or with too many. A planet with a tilt of 0 degrees has no seasons. The equator burns, the poles freeze, and nothing changes. But a planet with a tilt of 60 or 80 degrees, that's worse. Entire continents could bake under constant sunlight for half the year, then freeze solid in polar night. Monsoons could vanish. Jet streams would migrate unpredictably. Growing seasons would collapse. Ecosystems wouldn't just shift, they'd be uprooted. Humans depend on stable seasons for everything from agriculture to water cycles to public health. Even small shifts can devastate food production. A moonless Earth wouldn't shift gently. It would lurch. Evolution in the whirlpool. Over geological time, life adapts. But how fast? In a world with a constantly changing tilt, ecosystems would be locked in a permanent state of adjustment. Forests retreating and returning. Coral reefs blinking in and out of existence. Animal migrations losing their way. Ice ages arriving without warning or never leaving. Species might evolve faster or go extinct faster. There is no baseline, no steady ground to evolve from. Civilizations, too, would struggle to root themselves. Cities built on coastlines could find themselves underwater or marooned in deserts. Agricultural zones would shift across borders, forcing migration, conflict, collapse. How do you build culture, infrastructure, or history on a spinning world that won't hold still? Long-term chaos, short-term calm. Here's the unsettling part. None of this happens overnight. In the immediate aftermath of the moon's disappearance, the Earth would still feel normal, maybe even for decades. But over centuries, the wobble would begin. Over thousands of years, climates would shift. Over tens of thousands, chaos would take hold. This is the slow unraveling of stability. The kind of danger that doesn't scream but whispers, that waits patiently while we pretend things are fine, but by the time we noticed, it might already be too late to stop. What is home when the ground itself drifts? We like to think of Earth as a fixed thing, a home with walls that don't move. But without the moon, those walls bend. The floor tilts, the seasons run wild, and suddenly, home isn't what it used to be. Some nights feel heavier than others, not because of what's there, but because of what's missing. Imagine walking outside on a still summer night. No clouds, no city lights, just the endless dark stretching above you. But this time, something is wrong. Not broken, not out of place, just absent. No moon, no glow, no anchor for the eye. And you feel it, even before you understand it, like a silence in your bones. Because the moon was never just a rock in the sky. It was a memory, a rhythm, a presence that lived in us, even when we weren't looking. Its disappearance wouldn't just alter the tides, or tilt the Earth, or freeze the coral reefs. It would reach deeper, into biology, into psychology, into the mind of every creature that has ever looked up. What happens to the night when the night forgets itself? Lunar light and living things. For billions of years, life on Earth evolved under the influence of moonlight. It was the first, and for a long time, the only nocturnal light show. Some animals see the moon as a calendar, others a signal. For many, it's a survival cue. Moths, for example, navigate by moonlight. They use it to orient their flight, keeping the moon at a fixed angle, Remove the moon, and their flight becomes chaotic, confused. It's not just about light. It's about geometry, the invisible. Architecture of space and motion. Sea turtles hatch under the cover of night and find the ocean by crawling toward the brightest point on the horizon, typically the moon's reflection on water. In a world without the moon, baby turtles would crawl inland and die. Corals spawn in synchrony with full moons. Grunion fish time their aglaying to the lunar cycle. Birds migrate, insects breed, predators hunt, all guided by moonlight. These aren't minor effects. They are survival systems, written into the body over eons. And without the moon's light, those systems begin to fail. The darkness gets heavier. Moonlight is subtle, but it's enough. At full moon, it casts shadows, lights paths, ignites storytelling around the fire. It gives the night dimension. Without it, the darkness becomes absolute. The stars remain, but their light doesn't fall on your skin. They're too far, too faint, too removed from the earth. The moon was always the bridge, a nearby light, a visible orbit, proof that the sky moves. Take it away, and the night becomes flatter, colder, mentally distant. This can have real effects on the brain, circadian rhythms and moonlight memory. Humans are diurnal, wired for light and dark. But we also respond to subtler patterns. Some studies suggest that our sleep changes with the phases of the moon. During full moons, people tend to sleep slightly less. Even in modern, artificially lit environments, something in us still senses the moon's presence. A deep, ancestral timekeeper ticking just beneath consciousness. We evolved under this rhythm. Without it, the body might begin to drift. Melatonin cycles could shift. Sleep quality may decline. For those in high-latitude regions, where sunlight varies dramatically, the loss of lunar light could lead to deeper seasonal depression. For millennia, the moon was our nightlight. Now the light is out, and the night feels endless. Imprints of the moon in human behavior. Even our language carries the moon's imprint. Lunatic, moony, moonstruck, once in a blue moon. Entire emotional landscapes have been mapped to this one celestial object. In folklore, people change during full moons. Sleepwalkers, werewolves, lovers, criminals. Science doesn't always support these myths. But myths are not lies. They are echoes of something felt, something experienced. The moon stirred something deep in our limbic systems, even if we couldn't measure it. With the moon gone, what happens to those instincts? Do they fade or grow stranger? Cultural insomnia. Cultures, too, would begin to unravel a little in the moon's absence. Religious observances tied to the lunar cycle, like Ramadan, Easter, or various full moon festivals in Asia and Africa, would lose their timing anchor. Not because we couldn't calculate the dates, but because the symbol would vanish. Imagine celebrating the full moon when there is no moon. Lighting candles for a sky that no longer responds. Ritual loses its weight. And in the silence, a kind of spiritual insomnia begins. A world with no liminal space. The moon was a liminal object. Half light, half dark. Present, then absent, then reborn. It taught us patience, rhythm, and transformation. Its cycle mirrored our own, waxing and waning, gaining and losing. It was a cosmic metaphor, but also a lived reality. Without it, the sky becomes binary, day or night. On or off. We lose the in-between, the threshold, the quiet hour where the moon rose and reminded us, not everything in the universe is immediate. When we look up, What will we look for? We are pattern-seeking creatures. We look for faces in the moon, stories in its scars. When it disappears, we will try to replace it with science, with satellites, with meaning. But some losses can't be replaced. What does the night become when it loses its mirror? What does the human mind become when the sky forgets its oldest face? Long before telescopes, before science, before even writing, we looked up at the moon and saw a god, sometimes a woman, sometimes a man, sometimes a beast, a hunter, a watchful eye, but always something more than stone, more than light. The moon was never just observed, it was worshipped. Its face, constant and yet changing, haunted the imagination of every culture on Earth. It told stories, marked time, watched over the dead, inspired creation myths, prophecies, even madness down. Imagine all of that vanishing, not just from the sky, but from the soul of a species. If the moon disappeared, we wouldn't just lose a satellite. We'd lose one of the deepest mirrors of human meaning, a common thread across civilizations. There is no known culture, not one, that failed to recognize the moon in ancient Mesopotamia. The moon god Sin was among the oldest deities in Egypt. The ibis-headed Thoth ruled over lunar time and wisdom. The Greeks told tales of Selene, the moon goddess who drove her silver chariot across the night sky. The Norse spoke of Mani, pursued by wolves until the end of days. The Chinese celebrated Change, who lives on the moon in solitude, thousands of miles apart, thousands of years apart, but they all looked at the same sky, and they all saw something divine. The moon was universal, a shared symbol across oceans and empires, a celestial constant in a world of flux. Its disappearance would cut a thread that has tied humanity together since the beginning. The moon, as ritual lunar cycles, gave us more than myth. They gave us ritual. Lunar calendars shaped entire civilizations. The Islamic calendar is purely lunar. So is the Hebrew calendar. The Hindu calendar blends lunar and solar time, as do the ancient Babylonian and Chinese systems. Festivals, harvests, fasts, feasts, all tied to the phases of the moon. In pre-industrial societies, the moon told people when to plant, when to reap, when to mourn, when to celebrate. Its cycle, waxing, full, waning, dark, was the original metaphor for life and death, for growth and decline. The moon wasn't just in the sky, it was in time itself. If it disappeared, we'd still have clocks, atomic precision, calendars on our phones, but something older would be gone, something instinctive, a rhythm older than history, the moon and the unknown. The moon has always been a symbol of mystery. It appears and disappears. Its light is real but reflected. Its face always shows the same side, a permanent mask. It is close enough to see, but not to touch, familiar yet unreachable. In mythology, these qualities turned the moon into a liminal space, the border between life and death, reality and dream. The full moon was a time of prophecy, of transformation. In folklore, it marked the threshold when werewolves hunted, witches gathered, and spirits roamed free. These weren't just superstitions. They were the cultural vocabulary of liminality, of standing on the edge of something unknown. Take away the moon, and we lose a language we didn't even know we were speaking. Architecture of the sky, ancient monuments from Stonehenge to the Mayan, pyramids to Angkor Wat, were built in alignment, not just with the sun, but with the moon. Lunar eclipses, lunar standstills, the 18.6-year cycle of moonrise extremes. These rhythms were encoded in stone, wood, and fire. In some Native American cultures, stories of lunar eclipses were passed down as warnings or omens. For the Incas, a blood moon was a jaguar attacking the moon itself. In Japan, the moon inspired poetry, art, and even the concept of mono no aware, the gentle sadness of impermanence. Now imagine all that, sky architecture collapsing. The myths wouldn't die instantly, but their reference point would vanish. Stories untethered from the night. Future generations might look at ancient ruins and ask, what were they looking at? And the answer would be something that no longer exists. The spiritual vacuum. The moon has always provided more than light. It gave us a sense of presence, of watching, of cycles beyond our control. For many, it was a guide in prayer, a marker of sacred time. Without it, would the sky feel emptier? Would we project our stories somewhere else, onto Mars, or satellites, or screens? Or would a kind of cosmic amnesia set in, a loss of something we can't even name? What happens when a god disappears? Not with fire, not with blasphemy, but with silence. Asterisk, and then the question, if every civilization across time and distance revered the moon, if it appears in every myth, every ritual, every calendar, what does that say about us? Did we create the moon in our image, or did it shape the image we hold of ourselves? Some tools are so old, so deeply woven into the fabric of life, that we forget they were ever invented. Time is one of them, but time, as we understand it, is not a universal constant. It's a language, a map, a pattern humans carved into the chaos, and at the root of that pattern was the moon, its phases, its cycles, its soft, repeating arc across the sky. Now imagine that pattern gone, not gradually erased, but suddenly, all at once. No more full moons, no more crescents, more monthly rhythms to measure the shape of a life. The clock of civilization loses one of its oldest gears. And the question is, what stops turning next? The original calendar, before quartz watches, before sundials, before hours, minutes, or seconds. There were moons. Early humans tracked time by watching the sky. The moon, with its changing face, was the perfect celestial calendar. It waxed and waned predictably, marking cycles of roughly 29.5 days, a length now hard-coded into our concept of the month. The word month itself comes from munth. Many of the world's oldest calendars, Babylonian, Chinese, Hebrew, Islamic, are lunar or lunisolar. Entire civilizations scheduled their planting, harvesting, taxation, marriages, and religious ceremonies by the moon's rhythm. Take away the moon, and you don't just lose the calendar. You lose the origin story of when we are, time without a pulse. In modern life, we don't need the moon to tell time. We have atomic clocks, satellites, machine precision, but there's a hidden cost in forgetting the origin of a system. When time loses its roots in nature, in sky and cycle and season, it becomes something colder, more mechanical, less human, without the moon's constant visual cue. The idea of months becomes abstract, arbitrary, another leftover from a world that no longer exists. It's like keeping a lighthouse after the coast it warned against has vanished. How long before we change the way we count time altogether? The drift of ritual time is not just science, it's culture. People fast during Ramadan from moonrise to moonset. The Jewish calendar marks festivals like Passover and Rosh Hashanah with lunar precision. Easter is calculated as the Sunday after the full moon following the vernal equinox. Without the moon, these events could still be calculated mathematically, but something real would be missing. The symbol would vanish. The ritual would hollow. A child might ask, "Why is this day special?" And the answer would be a number, not a night sky, not a shared experience. When ritual drifts from nature, it becomes a script, repeatable but empty. How long before we forget what we were even trying to remember? Biological clocks unmoored. There's evidence that humans, especially women, have internal clocks that respond to the lunar cycle. The average menstrual cycle is close in length to the lunar month. Whether coincidence or deep evolutionary link, the resonance is striking. In some indigenous cultures, this connection was sacred. Women were said to follow the moon. The cycle was seen not as an inconvenience, but a connection to Earth's rhythm without the moon. Those rhythms persist, but they no longer have a mirror. Imagine billions of internal clocks still ticking, with nothing outside to sync to. A global case of jet lag. Not across space, but across memory. The disruption of institutions' civilization runs on schedules. School years, fiscal quarters, farming seasons, religious calendars, all of them evolved within a framework partly built on lunar rhythm. Without that rhythm, systems would adapt, but with friction. Agriculture might drift from traditional sowing and harvest dates. Cultural festivals could fall out of sync with the environment. Legal systems tied to lunar cycles, as some Islamic courts still are, would need reformation. It's not the end of time, but the fragmentation of shared time. And when people no longer agree on when they are, how long before they stop agreeing on who they are? Psychological time is not just a schedule. It's how we feel reality. Moon cycles once gave us a sense of ebb and flow, a way to mark progress, not in seconds, but in phases. Without it, the continuity of time can feel more flat, more endless. Days bleeding into nights, weeks into months, without landmarks, especially in places where seasons are subtle deserts, tropics, dense cities. The moon provided a scaffold, a pattern in the dark. Take it away, and for many, time may begin to blur. Disconnection, depression, the sense that nothing is moving, or that it's all moving too fast. Can time be real without something to look at? We often imagine time as a straight line, but maybe it's not. Maybe it's a circle, a cycle, a tide, and maybe, without the moon to guide it, we lose the very shape of time. Imagine a single thread pulled from the edge of a tapestry. At first, nothing unravels, but as time passes, fibers shift, patterns distort, and the whole design begins to fall apart. That thread was the moon. Its gravitational pull doesn't just move oceans, it holds together countless subtle systems, winds, currents, clouds, and climates. Take it away, and Earth begins to come undone. Not all at once, not with thunder and fire, but with strange silences, wrong winds, forgotten rains. We like to think the moon only rules the tides, but its influence runs deeper, all the way into the veins of the planet itself. Wind without rhythm, atmospheric tides, subtle waves in Earth's atmosphere are partly driven by the moon's gravitational tug. These lunar tides are much weaker than ocean tides, but they help modulate the flow of air across the planet. They influence wind patterns, jet streams, and even the behavior of storms. Without them, the atmosphere loses one of its oldest rhythms. The consequences wouldn't be immediate, but slowly irregularities would creep in, winds stalling in one region, accelerating in another, monsoons shifting unpredictably, dry spells arriving months too soon or months too late. Farmers who depend on seasonal rains would be the first to feel it, then cities, then entire continents. The moon's absence becomes a pressure drop, not in air, but in order. The climate's balancing act. The ocean and atmosphere form one vast system. Heat moves across the globe through this engine from equator to pole, from surface to deep sea, from water to wind. Tidal forces play a quiet but crucial role in this process. They help stir the deep ocean, mixing layers, keeping temperatures more uniform. Without the moon, this stirring slows dramatically. Warm water lingers at the surface. Cold water stagnates below. This stratification disrupts the flow of heat, and eventually, the entire climate system begins to twitch. It's like unplugging a hidden pump inside a machine that ran so smoothly we forgot it was even there. Now, it starts to rattle, storms without a steering wheel. Hurricanes are steered by high-altitude winds and ocean temperatures, both of which, as we've seen, are nudged by the moon's influence on Earth systems. Without the moon's regulating pull, hurricanes may become less predictable, even more intense. Tropical storms feed on warm, shallow water. If tidal motion slows, those waters become warmer. Higher sea surface temperatures mean more energy for cyclones. Slower moving storms mean longer, more destructive landfalls. The moon's disappearance doesn't create storms, but it unleashes them. Winds shift, seas rise. The planet's brakes are gone. The return of the ice or the arrival of fire. Earth's climate is not a single equilibrium. It's a tightrope between extremes. Our current climate stability depends on countless feedback loops. Clouds reflecting sunlight, snowpack insulating poles, ocean currents balancing heat. Many of these loops evolved in the presence of the moon. Take it away, and those loops begin to fail. Glacial cycles could speed up or slow down unpredictably. Warming trends might intensify, unchecked by oceanic mixing. Cold regions could swing. Hot, tropical zones could dry out. Climate zones, once stable for centuries, could migrate in a generation. The world wouldn't end in ice or fire, but it might end in chaos. Climate models in the dark. Here's the problem. Our best climate models assume the moon is there. Its gravitational influence is a given, a quiet constant in every simulation. Without it, we lose a crucial variable. In long-term prediction, suddenly, weather becomes harder to forecast. Historical data becomes less relevant. Trends become nonlinear. Our ability to adapt falters. It's not just the moon that's gone. It's the future we thought we understood. The chain reaction of small shifts. One of the moon's most underestimated effects is resonance. The idea that small, rhythmic forces applied consistently over time can produce enormous results. Think of a child swinging higher and higher with tiny kicks. That's resonance. The moon has been applying those kicks to Earth for billions of years. Take them away, and resonance reverses. Patterns decay. Systems lose their beat. Climate doesn't crash overnight. It just gets noisier, less stable, more prone to sudden, unpredictable shifts. From agriculture to infrastructure, from migration to geopolitics. The consequences cascade. a world we can't model. What do you call a system that looks stable until it isn't? A house of cards, or a planet? We've always thought of Earth as resilient. But maybe we've mistaken balance for permanence. And maybe the moon was the quiet hand that kept it steady, the damper on the chaos. Without it, we're left with turbulence. A sky that screams in gusts, a sea that forgets how to breathe, a climate that doesn't care what season it used to be. Rewind time, not centuries, not millennia, but billions of years, back to when Earth was still molten, barely formed, back to a time when the sky was red, the oceans were vapor, and the surface of the planet shivered under constant bombardment. Now, imagine this, a collision, catastrophic, precise, transformative, a Mars-sized object. The slams into the early Earth. Rock and fire erupt into orbit. Debris swirls, gathers, hardens, and from that apocalyptic storm, the moon is born. This is not a myth. It is the leading theory in planetary science, the giant impact hypothesis. But here's the twist. What if that collision never happened? What if Earth was never struck? What if the moon was never born? Would Earth still be Earth? Or would it be something colder, quieter, and dead? The collision that made us about 4.5 billion years ago in the chaotic early solar system, Earth, collided with Theia, a protoplanet roughly the size of Mars. The result was unimaginably violent. A portion of Earth's outer layers and much of Theia were blasted into orbit. Over time, this debris coalesced into a single, massive satellite, our moon. This event didn't just change Earth's orbit, it changed its identity. The impact likely tilted Earth's axis, setting the stage for seasons. It spun Earth faster, giving us shorter days, and critically, it gave Earth a companion, large enough to stabilize its tilt, pull its tides, and stir its oceans. Without that collision, Earth might have been just another rock. No large moon, no stable tilt, no long-term climate, and perhaps no life. The missing conditions for life. Life doesn't just appear anywhere. It needs liquid water, stable temperatures, and a climate that persists across deep time. The moon's presence may have created all three. Tides, caused by lunar gravity, may have driven the mixing of Earth's oceans, distributing heat and nutrients. Early life may have depended on these gradients to evolve. Axial stability kept in check by the moon ensured long-term climate predictability. Without it, Earth could have tilted wildly, swinging between snowball and inferno. Rotation sped up by the collision may have helped distribute solar energy more evenly, reducing temperature extremes. In other words, the moon didn't just influence life, it may have enabled it. No moon, no magnetosphere. Here's where things get even stranger. Some theories suggest that the giant impact also helped jumpstart Earth's core dynamo, the churning of molten metal that powers our magnetic field. That magnetic field is essential. It shields us from solar, wind, cosmic radiation, and atmospheric stripping. Mars, which lacks a strong magnetosphere, lost its water and most of its atmosphere billions of years ago. If the moon-forming impact helped stir Earth's core, then no moon might mean no magnetosphere. No magnetosphere means no atmosphere, and no atmosphere means no life. The chain is delicate, a domino that begins with a single crash, or its absence. Other worlds, other moons. When astronomers look at exoplanets' worlds beyond our solar system, they often wonder, Do they have moons? Because so far, large moons like ours appear to be rare. Most moons in the solar system are tiny captured asteroids, not forged in impact. Earth's moon is about 1/4 our planet's diameter. No other planet-moon ratio in the solar system even comes close. It's an outlier, which raises an uncomfortable question. Is Earth only habitable because of an accident? And if so, how many other accidents like it are out there? The moon as evolution's midwife. Even if life could emerge, without the moon, could it evolve? The moon's tidal pull didn't just stir the oceans, it created intertidal zones. These shifting shorelines, wet and dry, may have served as critical transition zones between sea and land. Some evolutionary biologists believe that complex multicellular life may have made its first tentative steps onto land because of the tidal cycle. Without the moon, that cycle is weaker. Shorelines become static, and life, even if it begins, might stay forever trapped in the sea. No trees, no birds, no humans. A coincidence too perfect. We orbit a star that's just the right temperature, on a planet with the right chemicals, with a magnetic shield, liquid water, plate tectonics, and a moon that balances everything. To some, this seems too precise to be random. Is it luck? Anthropic selection? Divine design? A fluke of cosmic billiards? There's no answer, only awe. And the recognition that without the moon, born from fire, we might never have opened our eyes to see it. What would Earth have been without that crash? A frozen sphere, a boiling wasteland, or a lonely ocean world drifting in silence? The story of Earth is not just the story of life, it's the story of impact. And without the one that made the moon, the story might have never begun. Somewhere in the galaxy, there's another Earth, same size, same atmosphere, same distance from its star. But look up, and the sky is empty. No moon. What happens to a planet like that? Would it flourish? Collapse? Would anything look back, as we search the stars for other worlds, other homes? The presence or absence of a moon may be more than a detail. It may be a dividing line between planets that breathe and planets that never even blinked. Because Earth, with all its beauty and chaos, may not be typical. It may be an exception, an accident of geometry and collision and timing. So what happens when we find planets that almost look like Earth but are missing that one silent companion? Exomoons, the missing puzzle piece. In the last few decades, astronomers have discovered over 5,000 exoplanets, worlds orbiting stars beyond our sun. They found hot Jupiters hugging their stars, frozen super-Earths circling red dwarfs, rocky planets in the so-called habitable zone. Not too hot, not too cold, but what they haven't found with certainty are exomoons. We assume they're out there. After all, every planet in our solar system except Mercury and Venus has moons, but detecting them, especially small ones, is incredibly difficult. A planet dims a star as it transits. A moon's transit is subtler, shorter, easier to miss in the noise. Only a handful of exomoon candidates exist, and none are confirmed with high confidence, which means this: we don't yet know how rare Earth's moon really is. Is the moon why we're here? If large moons are uncommon, and if large moons are essential to habitability, then planets like Earth could be vanishingly rare. Let's do the math. Only a narrow range of planets orbit in the habitable zone. Fewer still have the right size and composition. Fewer still avoid being bombarded or stripped of atmosphere. Fewer still may have the perfectly placed, oversized moon to stabilize their tilt, stir their oceans, and perhaps seed their life. This isn't just rare. It may be cosmically rare, and suddenly the disappearance of our moon feels less like a hypothetical and more like erasing the only example of something truly extraordinary. Other moons, other mysteries. Still, not all moons are created equal. Jupiter's moon Europa may harbor a subsurface ocean warmed by tidal flexing from Jupiter's immense gravity. Saturn's Enceladus shoots geysers of water vapor into space, containing organic molecules. Titan has lakes of methane and a thick atmosphere. These moons are not just dead rocks. They are enigmas, maybe even incubators. It's possible that some moons, not planets, are the true homes of life in the universe. But they are moons of gas giants, protected, heated, shaped by forces other than sunlight. Earth is different here. The planet is the stage for life, and its moon doesn't just orbit, it participates, it balances, it resonates. Take it away, and the play might never start. What counts as Earth-like? When scientists label a planet Earth-like, they usually mean mass, temperature, and atmosphere, but maybe that definition is too shallow. Maybe we should ask, does it have a moon? Is the moon large enough to stabilize the axis? Does it drive tides? Does it stir evolution? Does it echo in culture, in biology, in meaning? Because without those things, the planet may still be rocky, still warm, still wet, but lifeless, a mirror with nothing to reflect. Designing moons for habitability in theoretical models of habitable planets. Some scientists are now proposing a new parameter, moon mass ratio. They're asking what size of moon is needed to stabilize a planet's tilt, to generate meaningful tides, to last billions of years. It turns out the answer is slim. Moons that are too small, like Mars, Phobos, and Deimos, do nothing. Moons that are too big destabilize the system. The Earth-Moon ratio may be a narrow sweet spot. This raises strange possibilities for future terraforming, or even planetary engineering. Could we, one day, give a moon to a lifeless world? Could we seed a companion and wait for life to bloom? It sounds like science fiction, but maybe the fiction isn't about building moons. Maybe it's that a planet without one could ever truly come alive. Asterisk, are we alone? Because our moon isn't. The question of cosmic loneliness often focuses on stars, planets, or the sheer distances between them. But maybe it's simpler than that. Maybe we're alone because our moon isn't. Maybe the odds of everything happening just right, the size, the orbit, the impact that created it, were so astronomically slim that we're not just rare, we're improbable. And if the moon vanished, we wouldn't just lose our companion, we'd lose our cosmic fingerprint. Some absences are louder than explosions. They echo not in the sky, but in us. When the moon disappears, the Earth changes, but so do we. Not biologically, not instantly, but existentially. Something ancient begins to erode, not from the land or the sea, but from the mind. The moon has always been more than rock and light. It's been a mirror for our thoughts, our fears, our desires. A screen onto which we've projected our deepest selves. Without it, the night becomes just space, just stars, just black. And something in us begins to wonder, what are we now without something watching back? The oldest witness, For thousands of generations, the moon has been there, watching silently, present in every era of human history, every war, every birth, every extinction, and every revolution. It watched over the first fire, the first art, the first burial. It's been painted on cave walls, carved into stone, etched into tablets. Poets sang to it, soldiers marched under it, children dreamed beneath it. We have never known a night without it, not once in our species' memory. It's more than a celestial object. It's a psychological constant, a quiet witness that made the universe feel less alone. Take it away, and something unravels, not physically, but inwardly. Projection, the moon as the self. Carl Jung once wrote that what we see in the moon is often what we cannot find in ourselves. Melancholy, wonder, longing, reflection. The moon became a psychological mirror, an anchor for meaning that had no name. In its phases, we saw our moods. In its stillness, our yearning. In its glow, our search for something enduring. This projection gave the moon weight, not gravitational, but symbolic. In its absence, the mirror cracks, and suddenly we're looking into a sky that doesn't answer back. The moon in art, music, and madness. The moon has always haunted the arts. Beethoven's Moonlight Sonata, Van Gogh's star-drenched skies, the lunar metaphors in Shakespeare, Lorca Dickinson, Bowie. It symbolized madness, lunacy, love, lunacy, transformation, lunacy. Its absence would not simply mean fewer paintings of crescent moons or silver nights. It would mean an entire archetype collapsing, a loss of metaphor, of language, of creative gravity. What would a songwriter use to mean longing? What would a painter use to mean silence? The lunar loneliness. There is a unique kind of solitude under a moonlit sky, a quiet that holds space, not emptiness. That quiet would deepen into something colder without the moon. Astronauts describe the overview effect, the sense of awe and fragility when viewing Earth from space. But Earth has its own kind of overview effect. Looking up and seeing the moon, it reminds us we're on a planet, in motion, in orbit. Not the center of anything, but part of something vast. Without it, that reminder fades, and Earth begins to feel isolated, not just from the cosmos, but from itself. Cognitive drift, the subtle psychological consequences, studies on darkness, sensory deprivation, and isolation suggest that humans begin to unravel when deprived of patterned stimuli. The moon is one of the most ancient patterns we've ever had. Without it, we lose an anchor, not just for time or place, but for self. Sleep patterns may falter. Dream content may shift. Some researchers suggest the full moon correlates with increased vivid dreaming or altered REM cycles. Remove that cue, and subconscious patterns may degrade. There's a reason that in so many ancient languages, the word for mind or soul shares roots with moon. Maybe it wasn't metaphor, maybe it was structure. Grief for a silent sky. We don't just mourn the dead, we mourn the familiar. If the moon disappeared, there would be grief. Not just in the scientific community, not just in the headlines, but in homes, in hearts, in quiet conversations that begin with, "Does it feel different?" Children would grow up never knowing what their parents once took for granted. Photographs would become relics. Old poems would feel foreign. Moon-related words, lunatic, moonstruck, honeymoon would seem like echoes from a vanished world. Grief without a funeral, loss without a body, a mourning for something that once lit our darkness and shaped our silence. Can a species forget its sky? If the moon disappears, we adapt. That's what we do. But at what cost? Will the future look back at our moonlit past as a myth, a sentimental relic? Or will it ache for something it cannot name, a missing shape in the night? Because maybe we didn't just evolve under the moon. Maybe it evolved in us, a curved emptiness etched in the soul, waiting for a light that will never return. The moon is gone, but it doesn't leave alone. In its wake, a silence opens in the sky, and then, slowly, a tearing sound begins, not of atmosphere, not of thunder, but of orbits coming undone. For decades, Earth's space above the atmosphere has been stable, filled with thousands of satellites, debris, space stations, and spent rocket stages, all circling in fragile harmony. Each orbit calculated precisely, and many of those calculations included the moon. Without it, something starts to shift, not instantly, but relentlessly. The sky above begins to rot. The invisible architecture of orbit. Earth's orbit isn't just a blank canvas, it's a structured arena. Satellites occupy specific altitudes: low Earth orbit, LEO, medium Earth orbit, MEOW, and geosynchronous orbit, GEO. These positions are maintained with incredible precision, and they aren't isolated. They exist in gravitational context, affected subtly by the moon's pull. The moon's gravity stretches the Earth's orbital space, creating slight variations, perturbations in satellite movement. These variations are built into the math. They're background noise, but necessary noise. When the moon vanishes, that noise vanishes too, and suddenly the equations are wrong. The cascade begins. Without the moon's gravitational modulation, some satellite orbits become unstable, not wildly so at first, just enough to miss a maneuver, just enough to drift, just enough for one collision, and that's all it takes. Because in orbital mechanics, one crash isn't just one crash, it's the beginning of a Kessler syndrome, a cascading chain reaction of debris smashing into debris, creating an expanding cloud of shrapnel that can cripple satellites and destroy space infrastructure. The International Space Station, GPS satellites, weather arrays, communication networks, knocked out, blinded, falling. Earth without a sky. Modern civilization depends on satellites for navigation, banking, climate monitoring, emergency response, military defense, internet communication. Lose the orbital network, and Earth doesn't go dark, but it goes blind, and rebuilding in a debris-filled sky becomes exponentially harder. Every failed launch adds to the chaos. Every lost satellite limits our reach. A single moon's absence could, over decades, close the door to space. The lunar shield theory. There's also another possibility, more speculative, but deeply compelling. Some scientists suggest the moon acts as a gravitational buffer. It sweeps up or deflects space debris, asteroid fragments, and interplanetary dust that might otherwise spiral toward Earth. It's not a shield in the superhero sense, but a gravitational filter. Without it, Earth's orbit becomes messier. The solar system's floating junk has one less pit stop, and over time, our planet could see more atmospheric entries, more fireballs, more impacts, most small, but not all. The moon has taken hits for us. Craters bear the scars. Without it, we lose a kind of silent guardian, and the next hit might be ours. Lagrange points, broken balance. Lagrange points are gravitational sweet spots between the Earth and the moon, regions where spacecraft can hover with minimal fuel use. They're vital for deep space telescopes, solar observatories, and future lunar missions. With no moon, the Earth-Moon Lagrange system collapses. Stability is lost. Future missions have fewer options. Exploration becomes harder, more costly, more dangerous. The moon's absence doesn't just darken the sky, it shrinks our reach. The Great Recalculation. Imagine the world's space agencies reeling. NASA, ESA, JAXA, CNSA, ISRO, SpaceX. Every orbital model, every satellite. The moon is gone. But it doesn't leave alone. In its wake, a silence opens in the sky, and then, slowly, a tearing sound begins. Not of atmosphere, not of thunder, but of orbits coming undone. For decades, Earth's space above the atmosphere has been stable, filled with thousands of satellites, debris, space stations, and spent rocket stages, all circling in fragile harmony. Each orbit calculated precisely. And many of those calculations included the moon. Without it, something starts to shift, not instantly, but relentlessly. The sky above begins to rot. The invisible architecture of orbit. Earth's orbit isn't just a blank canvas, it's a structured arena. Satellites occupy specific altitudes: low Earth orbit, LEO, medium Earth orbit, MEOW, and geosynchronous orbit, GEO. These positions are maintained with incredible precision, and they aren't isolated. They exist in gravitational context, affected subtly by the moon's pull. The moon's gravity stretches the Earth's orbital space, creating slight variations, perturbation. Let's pause, step back, take a breath. So far, we've built a world of cascading consequences. Oceans stilled, climates shattered, satellites adrift, myths forgotten. But what if we're wrong? What if the moon, for all its beauty, all its poetry, all its gravity, isn't quite as essential as we think? Science is a mirror. It reflects what we know and what we assume. And sometimes, those assumptions run deeper than we realize. So in this moment, before the sky collapses, let's ask the question that real science demands. What if the story we've been telling isn't complete? Science, not certainty. The influence of the moon on tides, axial stability, and evolution is supported by strong models. But models are not laws. They are narratives, written in equations, and every model is an approximation. Take axial tilt, for example. Without the moon, simulations show Earth's tilt might vary wildly, but not always. Some scenarios suggest only modest instability over long periods. Some even propose that Earth's mass distribution and core dynamics could dampen chaotic shifts. In other words, we might wobble, but not fall. Same with tides. Lunar tides dominate, yes, but solar tides remain. Coastal systems would change, but not vanish. Life would adapt. It always has. And maybe the absence of moonlight wouldn't plunge us into psychological darkness. Maybe we'd just light candles earlier. Is that naive optimism? Or overdue humility? The problem of overfitting. When we look at Earth and the moon, we're looking at a sample size of 1. It's tempting to say, this happened, so it must be necessary. But that's a fallacy, post hoc reasoning disguised as inevitability. Just because Earth has a large moon doesn't mean Earth needs one. It may have helped. It may have accelerated complexity, but it may not have been essential. A moonless Earth might still have evolved life, differently, more slowly, under new rhythms, a different shape of wonder, and that raises a deeper problem. Maybe we're not asking What would happen if the moon disappeared? Maybe we're really asking, could we ever be without it? The anthropocentric trap: we are creatures of patterns and meaning and moonlight. So when we imagine the moon gone, we don't just fear ecological collapse, we fear a psychic collapse, a break in the mirror. But maybe that's ego, not evidence. Other life forms may not miss the moon at all. Maybe coral reefs spawn on solar cues. Maybe birds would orient by magnetic fields. Maybe human culture would shift towards solar metaphors, or even artificial moons, LEDs that replace reflection with simulation. What we think of as loss might just be change, uncomfortable, disruptive, but not fatal technology. As compensation, in the absence of the moon, we might build systems to fill the void. Artificial tidal generators to preserve coastal ecosystems, orbital stabilizers to mimic gravitational damping algorithms that replace lunar calendars with perfectly optimized solar ones, satellite constellations that simulate moonlight. Constant, programmable efficiencies. This dystopian, or just a new kind of normal. If the sky forgets us, do we build a new sky? The myth of fragility. We often imagine Earth as a tightrope. One variable changes, and it all falls apart. But maybe that's a myth. Maybe Earth is less like glass, and more like clay. It bends, warps, adapts. Over millions of years, it finds a new balance. The idea that we need the moon to survive may be true for now. But over geological time, the universe rarely depends on a single outcome. Life crawled out of chaos. It may do so again. Asterisk why this still matters. So, what's the point? If the moon's disappearance wouldn't destroy us, why ask the question at all? Because the question isn't about prediction, it's about perspective. When we pull one thread, we see how everything connects. When we imagine a world without the moon, we don't just test science, we rediscover it. Its interdependencies, its humility, its mystery. And maybe that's what we're really afraid of. Not losing the moon, but realizing we never fully understood what it meant in the first place. The moon is gone, but what if it wasn't alone? What if, somewhere in the quiet ballet of Earth's orbit, other companions have been circling all along, faint, flickering, forgotten? Because Earth may not be a one-moon planet, it may never have been. In this segment, we peer into the strange, overlooked world of quasimoons, Trojan satellites, and celestial shadows. Ghost companions that don't fit our neat definition of what a moon should be, but are there, orbiting us, or almost orbiting us. And in the moon's absence we ask, could anything take its place? What counts as a moon? The International Astronomical Union defines a moon as a natural satellite, a celestial body that orbits a planet. But what if that orbit isn't stable? What if it's temporary? What if the object moves in and out of Earth's gravitational grip? Not quite a moon, not quite a rock in space. That's where things get weird, because our planet is surrounded by more than just vacuum. It's surrounded by visitors, some short-term, some looping for decades, some that follow Earth like shadows, just out of reach. These are Earth's orbitals, its maybe moon, its other companions. 3753, Cruthen, the horseshoe dancer, discovered in 1986. 3753. Cruthen is sometimes called Earth's second moon, but it's not a moon in the traditional sense. It follows a bizarre horseshoe-shaped path that loops around Earth's orbit, sometimes ahead of us, sometimes behind. It doesn't orbit Earth directly, but it's gravitationally locked in a dance that lasts centuries. From our perspective, Cruthon spirals through the solar system in a slow, drifting rhythm, a cosmic partner we never quite touch. It's not stable enough to replace the moon, but it's proof that Earth's gravitational web is more complex and more populated than we imagine. Quasi-satellites, not quite moons. Quasi-satellites are a class of objects that orbit the Sun at the same average distance as Earth, but appear to loop around us due to gravitational resonance. Kamo Oeawa, discovered in 2016, is one such object. It's a small asteroid, just 40 to 100 meters wide, that has been following Earth for at least a century. It drifts in and out of our vicinity, like a ghost companion. Others, like 2010-7, Decay's orbit, near Earth's Lagrange points, those gravitational sweet spots where forces balance perfectly. These objects don't have the mass to stabilize our tilt or move our tides, but they're there, watching, trailing, flickering in and out of detection. The sky isn't empty. It's full of almost temporary moons, captured and forgotten. Every few decades, Earth captures a small asteroid. For a few months, sometimes years, it becomes a temporary moon. These mini-moons are rare, hard to detect, and often burn up in the atmosphere or slip back into solar orbit. In 2006, astronomers discovered 2006 RH120, a tiny object just a few meters across. It orbited Earth for over a year before vanishing back into space. These events are real, measurable, documented, and they suggest something profound. Earth may have dozens of moons over geological time, most too small to see, most gone before we ever knew they arrived. The moon we know isn't our only visitor, just our only survivor. Could one of these take the moon's place? In a word, no. None of these objects, Cruthon, Kamo, Oeawa, temporary moons, come close to matching the moon's size, mass, or stabilizing power. They can't hold the Earth's axis steady. They can't pull the oceans. They can't light the night. But maybe that's not the point. Maybe the lesson here isn't that another moon could replace ours. Maybe it's that the sky has always held more than we noticed. And maybe in the moon's absence, we would begin to see again, not just what we lost, but what we ignored. The future of synthetic moons. If the moon disappears, we might try to rebuild what we lost. Some scientists and engineers have proposed deploying artificial satellites to simulate moonlight for ecological, agricultural, or psychological benefit. China has even explored the concept of an artificial moon, a reflective satellite to illuminate cities at night, reducing energy costs. In a more ambitious future, could we engineer a new stabilizing satellite, launch a massive object into orbit to replace the moon's gravitational role? The physics are daunting, the cost astronomical, but the idea lingers because the need for rhythm, for balance, for a light in the sky won't go away. Asterisk, what else is out there? We've always thought of the moon as singular, unique, but maybe that's just perspective. Maybe Earth's sky has been full of forgotten companions, too small, too dim, too brief to matter until now. And maybe, in losing the moon, we would start to look harder, deeper, wider, not to replace what we had, but to understand what we never really saw. Space isn't empty, it's tension, balance, a web of invisible forces stretching across light years. Every object, from dust grain to gas giant, pulls on every other, and in that endless tug-of-war, the moon is not just an accessory, it's a node in the system, a weight on the cosmic fabric. When it disappears, the hole it leaves behind is not just psychological, it's physical, measurable, a wound in the equations of motion. This isn't about tides or myth anymore. This is about celestial mechanics, about how a single change in the local balance can ripple outward into the solar system, into orbits, into futures we don't yet understand. Earth-Moon-Sun, a three-body symphony. The Earth-Moon-Sun system is a delicate gravitational triangle. Earth orbits the Sun. The Moon orbits Earth, but the Moon also affects Earth's orbit ever so slightly. Its mass pulls on our shared barycenter, the system's common center of mass, which actually lies inside Earth, but not at its center. This wobble is subtle, but over time it shapes how Earth moves through space. Without the Moon, the barycenter shifts inward. The Earth becomes a simpler system. But simpler doesn't mean better, it means different. And in gravitational systems, different means unpredictable, orbital resonance, broken chords. Planets don't orbit in isolation. They form resonances, subtle patterns where their orbits speak to one another in harmonics. These patterns can stabilize systems or destabilize them catastrophically. Earth's orbit, influenced by the Moon, contributes to its long-term resonance with other planets, especially Venus and Mars. Remove the Moon, and Earth's slight orbital tweaks might push these resonances out of balance. That could mean tiny changes in Earth's distance from the Sun. Over thousands or millions of years. That's not trivial. That's climate shift, orbital decay, potential collision course, not with other planets, but with chaos itself. And it's not just Earth that feels it. The whole solar system adjusts. Planetary migration very accelerate in a distant, patient universe. Gravity doesn't need to act quickly. It whispers until the structure listens. Some theorists suggest that even small changes, like the removal of a single moon, could over eons influence planetary migration, the shifting of orbits, axial tilts, rotation rates. It's a butterfly effect across light years. A nudge here, an instability there, and suddenly a gas giant drifts inward. Or an asteroid belt destabilizes, or Earth's orbit, elongates. We tend to think of orbits as fixed tracks, but they're not tracks. They're compromises, temporary. Agreements between gravity, inertia, and mass. Remove one piece, and the negotiations begin again. The absence of eclipses, the silence of alignment. One of the most haunting losses in a moonless sky would be the end of eclipses. Solar eclipses happen because the moon is just the right size and distance to cover the sun perfectly. A cosmic coincidence. No other known moon creates such a phenomenon. Without the moon, solar eclipses become impossible. Lunar eclipses vanish too. An entire cosmic dialogue, light and shadow, timing and alignment, ends. Astronomers lose one of their most powerful tools for studying the sun's corona. Cultures lose one of the most awe-inspiring spectacles nature offers. The sky becomes less interactive, less layered. Just light and dark, never both at once. A hole in the harmonics. The moon is 1/80th the mass of Earth. That might seem small, but in cosmic terms, it's a powerful note in the solar system's chord. Every planet, every moon, every ring, and comet and asteroid, they all play in this music. Gravity is the string. Orbital motion is the sound. The moon gives Earth a kind of timbre, a harmonic texture that affects more than we realize. Remove it, and the chord changes. Maybe subtly, maybe catastrophically. but the harmony is not the same. It's like pulling a violin out of a quartet. The others still play, but something vital is missing. A richness, a layer, a depth. The music becomes thinner. The deep future echo in 1 billion years. The sun will swell. The earth may be scorched. The moon, if still present, would have drifted farther away. But if the moon disappears now, that drift never happens. The Earth's spin rate changes. Its orbital dynamics evolve along a new path. The history of our solar system rewrites itself, not at once, but gradually, line by line. We may not survive to see it. But gravity has all the time in the world. What else do we take for granted? We think of the moon as ours, but it's not just for Earth. It's part of a larger system, a cog in a mechanism far more intricate than we understand. And when that cog is removed, the machine doesn't crash. It whispers, it shifts, it forgets how it used to sound, and the universe continues, but with a different beat. There is no alarm, no explosion, no flash of light, only a silence so complete, it feels like forgetting. The moon is gone, and the world keeps turning. The oceans stir more slowly. The nights grow darker and colder. The sky seems deeper, but emptier. You walk outside, look up, and for a moment, you don't know what's missing, until you do. Not just the light, not just the tides, but the feeling, the presence that something was there, watching, reflecting, guiding. Now it's just stars, distant, indifferent, beautiful, but never familiar. A vanishing that echoes. The moon didn't die, it didn't shatter, it didn't even make a sound. It simply ceased to be and left the earth to notice. In the absence, things unravel. Not always fast, not always visibly, but deeply. Calendars fracture, seasons blur, tides quiet into stagnation. Rituals drift from memory. The night becomes just a pause, not a presence. We adapt, of course we do. We build new systems, launch satellites, program our own rhythms. But beneath the wires and algorithms, something aches, the shape of what's gone. The moon was never ours to keep, but we made it ours, with stories, with meaning, with memory. It wasn't just light in the sky, it was time, it was change. It was a mirror we held up to ourselves, and saw not answers, but questions. It reminded us we were part of something turning. Now without it, we drift, not wildly, not catastrophically, but hollowed, like a song missing one note, like a home missing one room, like a night that lost its name. The final question: maybe the moon was never necessary. Maybe Earth would have survived. Maybe life would have crawled out anyway. Maybe civilization would have found other metaphors, other mirrors, other myths. But maybe we needed the moon not to live, but to understand that we are alive, to measure time not just in hours, but in cycles, to see not just darkness, but reflection, to look up and know we were not alone. Full circle, and so we return to that first quiet sky, the one where the moon never rises, where the stars burn on, but the night never looks back. And somewhere, deep in the bones of the earth, in the tides that no longer reach, in the trees that forget when to bloom, in the minds of those who still remember to look up, there is a silence, not empty, not final, but sacred. A silence that says, something was here, and it mattered.